Well, thank you for joining us today for this webinar. I wanted to answer the first question is why we are doing this webinar to begin with, and this one in particular on campus utilities. About a year ago, I had a conversation with the facility manager working for a school district, and he gave an account of one of their contractors working on a water line replacement project. And during that project, they struck an underground electric line that caused severe injury to several workers, and it could have very easily caused fatalities. And after he explained the situation, it quickly became clear that had the school district had a GIS in place with accurate utility information, this accident could have been avoided altogether. And today I'm hoping to provide you with some helpful steps towards improving the safety of your campus staff and contractors by way of better, more accurate utility records within your GIS. So today we'll be focusing specifically on the ArcGIS platform, which provides campuses with an integration platform for facilities and utility data. So just an overview of the main topics we'll be covering today. First of all, we're going to discuss the centralization of those utility records, combining those all in one place. And then increasing spatial accuracy. We'll give some tips on how to do that when it comes to your positional accuracy of your utility data. And then also data quality, attribute information, and how to best improve that. And then we'll follow that up with a brief demo in ArcGIS Pro. I'm going to give you some geoprocessing tips on cleaning up your utility data. And then we'll touch lastly on the utility network. We won't get too deep into that. We'll just make some comments on that and then a couple items on what's coming down the pipeline. Okay, so centralizing your utility records. There's some options out there, but mainly as we look at the ArcGIS platform, if you're looking to really kind of bring everything together and you're just getting started, definitely would recommend looking at ArcGIS Online. If you've got ArcGIS Online, maybe you've got ArcGIS Enterprise as well. Definitely great resources to have, but the point is to bring it all into one single data repository that solves the problem of where is the most current utility information? How do I know which version is current? And then, giving you a lot of different options on what to look at and where to have it. So it's all in one spot. That way there's no confusion. So I wanted to show briefly, if we look, there's an Esri resource as we look just as one example of utility on water utility. And as we kind of expand on this, water system data management, we have this example where you can use mobile devices. Obviously, the big one is, field maps with ArcGIS, and we'll get a little bit more into that. But Esri has a lot of templates that you can start with. And so that's a great starting point as we look to add everything into a central repository. So one of those examples that I just mentioned was the water distribution one. There's also solutions you can get started with wastewater. Those are all great templates that you can get started with. But you basically, a lot of the ideas to convert, first of all, to get them into the data repository, you're going to start by converting them from CAD layers. Now, there's an incredible amount of CAD data out there. So don't be afraid to reach out to past consultants you've worked with that maybe have CAD data that your campus, is maybe doesn't have readily accessible. Be willing to ask around, though, make some phone calls and see what kind of CAD layers are out there that you can use for starters. And then storing your utility data in a database structure. So this is sometimes referred to either as a data schema or an information model. With the utility network, there's the asset packages that are referred to when it comes to what format and schema to use. But like I mentioned, those Esri templates are really good. Good starting point. They've got them for water, wastewater, telecom, a lot of different options there. So they're a good place. Like if you're just using ArcGIS Online, you want to deploy those very quickly. They're very simple to deploy, and it gives you the mapping, the shared maps and apps. It's kind of a turnkey solution, but you can also extend the use of those schemas that they give you, those templates, and services and maps, you can extend the use of those by making additional fields you can add and workflows and capabilities that way. And if you need additional help, there are obviously Esri partners available to help with those, such as we are here at CloudPoint. So separate utilities is important. As you think about separating your utilities into different feature classes, you're going to want to make sure you do that. And I think that's just standard practice, but it is something very important to separate into those into different feature classes, having those all in one database. And then building relationships with your end users. I think this is really important as we talk about bringing all the data together. You want to talk with your users and your maintainers of the data and ask questions such as, has the GIS been a reliable source of information for you? Is there anything we can do to improve the experience for you? Those are important questions as we think about bringing it all under one umbrella and making sure it's useful to people. The last thing we want to do is centralize everything and then share it and have nobody be taking advantage of it and using it. Next, I wanted to talk a little bit about the increasing of the spatial accuracy. So again, the single data repository solves some of those problems of, where is it most current, the most current information? How do I know which version is current? But we find that there's also the need for improving the spatial accuracy. And with the spatial accuracy, there's different ways we can improve that. And obviously some of those are investing in equipment or hardware. A few of those examples here we talk about is drone mapping, where we can definitely take advantage of high accuracy drone imagery and GPS units with GPS collection. In this example, we've got a Trimble unit in the photo there that ties directly into a mobile device running field maps, which are great tools to improve your accuracy that way. Another one is scanning equipment. This example shows an external scanner, what we call a SLAM scanner. And those are good for both indoor and outdoor collection. And those can really help you get very highly accurate information on your utilities as far as that spatial location. And then just being able to establish some clear, streamlined workflows on getting those into your GIS as you increase that accuracy. Just some tips to consider when collecting it and to increase your spatial accuracy. You want to collect the utilities, obviously, when they are exposed, located, or marked. Some of the nice things as you consider the advantage of maybe drones over GPS units. When you have all of your utilities marked and you fly, say, a site-specific area with a drone, you're automatically, if you have the high accuracy you're collecting your drone imagery with, maybe you've got a drone that's GPS enabled to get you higher accuracy there. But you automatically pull that into your GIS. You've got your map essentially there for you. You're just tracing points on that map, which makes it very simple, straightforward, and really streamlines that workflow. So when you find opportunities where you have utilities marked, if you have construction projects going on, make sure you get out there at the right time and take advantage of those being pre-marked to help build the spatial accuracy of what you've got there. Also consider electronic data submittals. So if you have consultants you're working with and they're delivering CAD data, please consider making requirements, specify the coordinate system you want it delivered in, specify the accuracy requirements of what those utility as-builts must be delivered in. But definitely, and if you need to, have a vendor meeting with those consultants that you work with regularly and ask questions, see what they can deliver and maybe what they struggle with delivering. But those are great ideas on how you can improve that accuracy just from your whole workflow of as-builts and working with vendors. Okay, so just specifically as we kind of dive into ArcGIS field maps, what are some ways and some simple ways to improve the accuracy of the data you're getting in the field? You may be on your own as far as data collection in the field and what you're collecting for as-builts, or you might have a team of people in your GIS department that you're using to gather this information. Within field maps, there are some great tools, features that are available. I think of it as the 3 Ps I've got listed here: provider, profile, and position. You can see in the photos there, I've got provider and profile are simple. They're listed there. Integrated is if you're just using the native GPS from the mobile device, but if you want to improve that, if you were connected, say, Bluetooth to a Trimble unit, for example, that would show up right there under provider. You would select that Bluetooth GPS unit. For profile, again, that's just setting your profile of what you want that map and that collection settings to be as far as coordinate systems, and that'll be important that you want to consider that. Positional accuracy, very important. Field maps allows you to change those settings. So here in the example on the right, we see that this accuracy is collection settings is set to 2 inches. This means that a point or a location will not be collected unless the GPS signal is providing you 2 inches or better accuracy. And again, that's a setting you can make that you can make it as large as you want, depending on how accurate your unit is that you're using to collect with. Another tip on the collection settings is averaging GPS points. So if you think about it, GPS averaging, your unit can collect 5 positions before it assigns that point location. So that's really advantageous, as it's taking an average of 5 points. It's going to get you more accurate information on that. So those are both helpful tips when it comes to using field maps specifically as you go to increase spatial accuracy. Okay, improving data quality. So it's important as we think about data quality that what we find many times is it ends up being a trust factor. If end users do not trust the GIS, they're not going to use it. And so as we think on how can we get the best information collected in the GIS, it's important to think about how we're going to share that utility data. We have to share it to build trust, but we also need to share it to get feedback from those users to improve the data quality. And so, as I mentioned, field maps, great way to coordinate with your field staff on accessing your utility information, but then updating the records of that as well. So I would highly encourage you to give editing privileges to your folks that are in the field to be able to update and streamline your utility information, your as-builts and your updates. That's very important. And field maps, Esri is pouring a lot of resources into it, a lot of development. They're really merging a lot of capabilities with the utility network, tracing, for example, into field maps to make that more user-friendly. Another thing to think about when considering sharing your utility data is start thinking of a web app mentality. And what I mean by that is not all of your users, most of them are not going to be using ArcGIS Pro. They may have used ArcMap in the past, but now with the ease of converting web maps into applications for users to edit, I would highly encourage you to start thinking of the web app mentality and building web apps for your users. Also create feedback tools. How can I get easily in the hands of my end users who are out in the field, who are the ones digging in the dirt, so to speak? How can I get their feedback on my utility maps to improve that data quality and my attribute information? How can I get the best accurate information on what type of material is it? What's the diameters? So having feedback tools in place, items such as map notes, add those to your maps, as well as Survey 123 forms can all be valuable to get that feedback. And then simplifying the required fields. Just remember, if you have too many attributes, it can be difficult to maintain all those. So the more you can simplify those, the more use you're going to get out of those, and the more likely that those are going to be kept current and updated. And then lastly, as we think about improving that data quality, there are geoprocessing tools that we can take advantage of. And this is really important as we think about cleaning up our utility data, because the number one thing I hear as people migrate toward the utility network, the biggest challenge is cleaning up your data. If you've come from and you already had your utility data in some type of network, it's a little bit easier to make that leap. But if you're going from just having it in points, lines, and polygons, and you're going to import that into a network, you're going to have a lot of data cleanup. There's just no avoiding it, really. So what I wanted to do is just take a moment to jump into ArcGIS Pro and show some helpful geoprocessing tools to consider when cleaning up data. So I've got some water utility data here as an example. And I've got 3 areas that I wanted to highlight that are messy and dirty. You can see these lines are disconnected. Got some dangles in these areas. I've got another area where they should be connected and they're not. And, finally a third area here. So what I wanted to look at is talk through how can we go through the process of cleaning these up. And I'm going to run some geoprocessing tools to just kind of get you thinking on some different ways we can do this. So the first one we're going to do is feature to vertices, and excuse me, we'll do vertices to points. And we're going to convert the endpoints of our lines to point features. And so what I want to do is I'm going to select both start and end vertexes. I don't want to select anything in between. I just want my endpoints. So as I run that, we'll see it will develop some points there on those endpoints, and it's added to my map. And what I want to do next is I need to find a way to kind of average out these points in between, because I need to create a point in the middle of them that I'm going to snap to as I do my cleanup. So there's a tool called point clusters, find point clusters. And we're going to run that on this layer that we just created. And what point cluster is going to do, it'll take just a minute here. We're going to use distance. And for this example, we're going to say a minimum of 2 points per cluster, because I want these points to be clustered together. And I'm going to do a search distance. I'm going to say 3 feet. So we'll say 3 feet there. I'm going to go ahead and run that. And what this is going to do is it's going to create another layer of point clusters, and it's going to color code those points based on which cluster they belong to. What it's also doing as it does that is it's also going to assign what we call cluster ID. And so that cluster ID is going to be the field that we're going to use to tie those together. So here you can see my results are done. It's given me colors according to the cluster they belong to. Okay. And I'm not done yet, because again, I want that point in the center. I want to have the center of those clusters show up. So I'm going to run one more geoprocessing tool, and we're going to run the dissolve. And what we're going to do is dissolve the features that we just created. We're going to dissolve those based on the cluster ID field. Okay, and I do want to select, I want it to create multi-part features. So I definitely want to include that. And we will go ahead and run that. And it should give me 1 point, excuse me, it's given me points at the same locations, but those are multi-part features. So lastly, I just want to run a feature to point to get those cleaned up. And I'm going to select that dissolved one that came up, and I'm going to go ahead and run those and say it's going to be a feature to point, and it's going to take the multi-part and convert them to 1 point, and that should show up in the center there for us. You can see my newest layer created a point in the middle. If I turn these other ones off, it'll kind of help clean that up. So this is what we're left with. We're left with a point where each group was in each cluster, and I can see that at each location. And now the last thing I need to do is I need to snap my lines to those points that we ended up with. So in order to do that, I'm going to run the snap tool. and I'm going to specify my line features. So I'm going to select water lines, and I'm going to snap those to my latest point feature, and I'm going to snap just the ends, and I'm going to give it a distance again of 3 feet. We'll select feet, and I'm going to go ahead and run that. And my water lines are now snapped to those points. So this is just some helpful tools and tips as you go to clean up your data. This is one that was definitely helpful to be able to join all your endpoints of your lines together and make sure you get that started in the right direction as you import that to a network. One more tool I wanted to share, which was really helpful. I ran into a situation recently where I was trying to move one, like we'll say a node, and I wanted the lines to follow it, really using what's called map topology. There's different ways you can create topology, but if you select map topology in this situation and you go to edit vertices, we have an additional option over here on the right under our edit vertices dialog box. It says edges, and I'm going to select edges, and it's allowing me to select either an edge or a node. In this case, I'm going to select a node, and I want to move this node and I want the lines to follow. So that's what we're doing here, and I'm going to accept that, and then you can see the lines automatically go with that. So this is really helpful, again, to be able to save you time in editing if you're just doing some digitizing work and moving these around. Or let's say you shot GPS points and you wanted to snap these lines to your GPS points, you could use the snap feature we showed you earlier. So just some helpful tips on data cleanup and some tools that might be useful for you as you go to clean up your utility data. Okay. So moving on here, just kind of some comments as far as the utility network goes. This is definitely something we're seeing a lot of interest in. I think the main thing is for people to understand that it is a big leap to go into the utility network. But we've got some really helpful resources and things to consider. But organizations that want to go beyond the simple asset mapping and implement more advanced network capabilities, this is a great transition, and it really, it shares an aligned data model with the solution that streamlines the past, so you can have some more robust capabilities. But the UN provides a foundation, or excuse me, there's a UN foundation that Esri has available that gives you that starting point, and it really builds intelligence into these networks and helps with decision making from that standpoint. So it's not just maps and symbols, points and lines and polygon features. It's now a way to really build intelligence into your utilities and get some decision making out of those, such as upstream and downstream traces is a really popular one, and being able to model your utilities in more detail. So for more information, Esri's got a great playlist out there. We've also got a playlist on our YouTube channel. Feel free to check those out. We've got several, I think we have over 70,000 views on these videos collectively. So great resources, but be sure before moving to the utility network, be sure to ask yourself why you want to do this, why you want to move into the UN, and make sure that your use case is compelling enough because it is, again, it's a heavy lift. A lot of that involves the data cleanup work. But questions to ask yourself: what benefits do I hope to gain by moving in this direction? What additional functionality would I like to see out of my utility GIS layers? And how good is my data? How much cleanup is going to be required? And then also a really important question is, do I have the staff with the knowledge or the skill level to be able to support this and maintain it moving forward? All right, and just some comments on what's coming down the pipeline. So we're seeing more demand for indoor utility mapping. And you might say, well, how do you accomplish this? Indoor utility mapping. Well, some of the tools, we mentioned the scanning device earlier, with SLAM scanning is one of the tools. You can actually take these scanners and you can remove ceiling tiles, and you can put the scanner in the ceiling and you can collect scan information that way as well. So just one example, doing this performing these while say the drywall or the finish is not yet on, so you can see your utilities exposed in the walls during construction renovation. Another tool is for that is 360 imagery. So we're seeing one common provider there is called Matterport. If you're familiar with Matterport, they've got a great 3D imaging solution out there. They have a cloud-based subscription. It's kind of like Google Street View on the inside of your buildings. There's others that integrate better also with ArcGIS, and now they're starting to create integrations with experience builders. You can tap right into your 3D imagery and panoramics, and I think we cover that in some other webinars where we talk more in detail about those. Last thing I wanted to mention was coming down the pipeline, digitizing with using AI. This is a really powerful tool. I just learned about this recently, but now they're reading engineering drawings with AI rather than using just OCR, the recognition for text. Now they're starting to be able to recognize not only text, but also shapes and symbols. So they can actually start to digitize using AI. One of those companies I came across here had a whole article on it, talked a little bit more in depth on that, but it's pretty fascinating the direction that those are moving in. So just kind of some things that we keep in mind moving forward and what's down the pipeline. Just some additional resources, and I want to give credit for Esri for just some of the information I was showing you today, especially with the data management solutions for utilities. They also have a Smart Campus Operations webinar series, which is really helpful. Justin Anderson and Brian Baldwin have been involved with those, and those are really excellent. I also wanted to mention Campus Facilities Technology Association, CFTA for short. It's a great organization to be a part of. If you're involved with maintaining facilities or utilities, any kind of technology with GIS, definitely a great group to be a part of. They're actively recruiting additional members from K-12 schools, but they have an annual conference, they have webinars, they also have monthly water coolers. It's a great resource. If you're not a part of that, you might want to consider that. So, and I think that's all I've got for today. I'll turn it back over to Sahara.